We're going to be discussing today the work that we've been doing on Stencila schema, which is a set of extensions to schema.org in support of structured executable documents. We're joined today by an awesome team of panelists. And just so you know, we're really aiming to get a whole lot of feedback out of today's call. We're hoping to get a version 1 of the schema out in the next couple of weeks. So it's important for us to get all your feedback and comments and suggestions on what we're doing here. So we've set up a Google Doc that is available in the chat channel. There's also a link to that on the blog post, I think. So you can jump in there and feel free to ask questions. I'll also ask everyone on the call just to respect each other and our code of conduct. There's a link there. And I just wanted to shout out that this is a first in a new series of webinars that we're doing at Stencila, covering each of our tools. The schema is really central to a lot of what we're doing, so we've decided to start off with that. It's sort of more at the geeky end of the spectrum. We'll be talking a lot about schemas and JSON. And I suppose as we go through these webinars, we'll be going more towards the user-facing tools. But as I said, this is sort of foundational work for us, so we thought we'd cover this first. As I said, we've got some great panelists along today to come and help share their thoughts on what we're doing. So I'm going to ask them all to introduce themselves. And we'll just go through in alphabetical last name order. So I think that's Dana. Could you start?
Yeah, sure. So I'm Dana Boquin. I'm the head librarian at the Center for Astrophysics, which is a collaboration between Harvard and the Smithsonian. And so we kind of serve a pretty diverse community of researchers who work on all kinds of things that include, you know, kind of necessitate, I guess, my library working on projects that have a lot to do with linked data. And so I think that that's probably why I was brought in here. I'm the PI of a project called Metasat, which is a metadata toolkit for describing satellite missions. And so it's mostly to focus on connecting hardware, software, and data descriptions for satellite missions, because we serve a community that focuses on engineering as well as the science and of what comes out of those missions. And so happy to talk more about any of that, but it's optimized for JSON LD, and so looking forward to seeing more of what's going on here. Yeah.
Thank you. Thad.
Hi, I'm Thad Guidry. I'm a retired engineer, data architect. A little bit about my background. It's primarily been in the enterprise as well as open source world, and kind of back and forth over the years. I'm one of the original contributors within schema.org, and more recent, or within the open source world, also contributing to OpenRefine, which is a data cleaning tool that a lot of data journalists and scientists use around the world.
Thanks. Dan, did you want to go next?
Sure. Yeah, I'm Dan Katz. So I'm Assistant Director for Scientific Software and Applications at NCSA, which is the National Center for Supercomputing Applications at the University of Illinois. And I'm a research associate professor in computer science, electrical and computer engineering, and our School of Information Sciences. I guess the things that I'm doing that are relevant here are that I was a co-chair of the Force 11 software citation work, originally that led to the software citation principles with Arfon, as well as Kyle Niemeyer. And I'm a co-chair of the group that's now trying to implement those. And so we're coming up with policies for journals and for authors and software developers about how to describe software in a way that gets it into the scholarly communication publishing system. I'm also a co-PI of ERSI, which is an activity that's trying to conceptualize a software sustainability institute in the US. basically, I guess, trying to improve the life of software developers and the respect that's paid for software in the US. I'm a co-founder and steering committee member of the US RSE organization, which is the US Research Software Engineer Association, which is basically trying to build career paths for people that are RSEs and help them work well in universities. I'm associate editor-in-chief of JOS, which I'm sure Arfon will talk about, so I will skip that one. Yeah, I think that's enough.
Great, thanks, Dan. Paul, you're next on the alphabetical list.
Okay, hi, I'm Paul Shannon. I'm the head of technology at eLife. Been there around 4 years now, coming at a time just after they'd released their first open source piece of software. Since then, really taking that out to build communities and ecosystems around the software that we've been building, working with people like Stencila and other great collaborations as well. More recently, I've been working sort of slightly separately to eLife, still within it, on working on our publish, review, curate platform that we're producing at the moment. And that's where we've been looking at using schema.org so that we can, and then the extensions that we've got from Stencila, so that we can really expand the way that people can consume data around preprints and reviews and bring all those things together in a nice, easy to use place.
Thanks, Paul. Arfon.
Yeah, hi folks. My name is Arfon Smith. I am a lapsed academic, I think is probably the best way to describe me. I have a background in astronomy, astrochemistry specifically, but I've sort of spent most of my career building tools that enable research for others. So the things that sort of align mostly with me in my work and what we're talking about here today, I've been involved in a few different projects. One was this project called Code Meta, which was sort of about sort of software metadata schemas across lots of different, sort of unifying lots of different existing ontologies, vocabularies, and that relates to schema.org as one of those. I was most recently running a group called the Data Science Mission Office at Space Telescope Science Institute in Baltimore. They fly the Hubble Space Telescope and we'll be flying the James Webb Space Telescope. And we had a lot of data archives there, and metadata and standards around those were incredibly important. Some nice established standards in astronomy. As Dan mentioned, I'm the editor-in-chief of the Journal of Open Source Software. It's a project Dan and I and others started together about 4 years ago. We published about 1,000 papers describing research software, and we really care about sort of the tooling that's under the hood there. So one of the kind of general challenges we have is kind of doing a good job of representing software together with the paper that's being written about it. So we're always looking to sort of for innovations in that space. And finally, the last thing my day job is I'm actually at GitHub as a product manager in the data organization. And so we're sort of generally interested in how, you know, GitHub can be a better participant in sort of representing the content that's on the platform. So I think I'll stop there.
Thank you. Last but not least, Vanessa, thank you.
Last but not least, hi everyone, I'm Vanessa Sochat. I'm a research software engineer at the Stanford University Research Computing Center. I'm really passionate about sort of building and contributing to software pertaining to containers and workflows. In context of the discussion today, I maintain a schema.org Python module. I also have contributed container specifications to Stencila now because I think discoverability of containers is really important. So let's talk about that today. And I'm excited generally for Stencila because I think there's a really huge opportunity to like better improve collaboration between these many different parties of people that are all interested in this metadata.
Great, thank you. Okay, let's get into it then. I'll share my screen again. So the agenda for today's call, we're going to split it up into 3 main parts, and we're going to stop for discussion in between. So as I said before, feel free to ask questions and we'll try and answer those as fully as we can during the call. It's all about discussion. First section is really just an overview of what this is, why we're doing it, and how we're doing it. We're going to then go into a bit more of a dive into the types around metadata and prose. Stop for some discussion there, and then get into discussing some of the types around data and code, and then we'll wrap up. So we've got a lot to go through, so I'll get right into the what and what we're trying to achieve here. So the Stencila schema is a set of extensions to schema.org and other vocabularies in support of structured, semantic, and executable documents. So what does that mean? I think it's useful to think about different types of documents that we deal with in research, and their structure and their semantics as well. So let's think about a word processor document, something like a docx file. It's a document that is heavily structured. It's represented as a node of XML in that case, where you can have tables with paragraphs within table cells, and it's highly nested. Then we've got things like spreadsheets, which are not so complicated. They're not so highly nested. They're just really two-dimensional objects, but they add this element of code and interactivity to them. We see a similar pattern with notebook formats. Here we have the interactivity brought in through having code chunks that can execute code in external languages, such as Python and R. And we've got in between those code chunks bits of text. Often those are just blobs of markdown, which have some structure in their own sense. And then we've got publishing formats such as JATS, where we're capturing a whole lot of metadata around that article, such as the authors and their affiliations and funding and IDs and citations and so forth. So each of these formats has their main emphasis, and what we're trying to achieve here is there a way that we can come up with a data model that will capture various parts of those different formats. So why did we do this? We at Stencila needed a data model to reflect the executable documents that we're trying to achieve. So they're highly structured documents that have a lot of different types of nodes. So we needed a data model that was rich enough to capture those different types of document nodes. We didn't want to make up a new data model by ourselves, and hence that's why we've focused on the extensions to schema.org. And we wanted a data model that was easy to integrate with existing systems. So something that, again, we weren't reinventing the wheel, that we could pick up from elsewhere. Why are we doing this? I mean, ultimately, this is about trying to achieve our goal of reducing the time and burden on authors to publish discoverable content. And I think that's a key aspect of what we're doing. As you'll see, when we publish these documents, we're able to, because of our links to schema.org, make them highly machine discoverable. But it's also about empowering readers to then explore that research and reuse the latest research that's getting published. So schema.org, for those of you that aren't familiar with it in the audience, it's a project that has been set up and is backed by a number of search engines, and it has a mission to create, maintain, and promote schemas for structured data on the internet. It has a wide variety of different types that it reflects. In this big circle diagram here, you can see it includes things like medical organizations, educational organizations, music playlists, numbers, residences, and so forth. What we're really interested is this section up here around creative works. And I've shown just a snippet of the types that are in schema.org around creative works, including articles, scholarly articles, and medical scholarly articles. So schema.org looked like a good starting point for us to base our own schema and to extend it where we needed to. In addition to schema.org, there are already existing extensions and projects that are building on top of it, and those that are focused on research. Arfon mentioned the Code Meta project, which has various crosswalks for converting existing metadata schemas from things like R and NPM packages into schema.org compatible schemas. We've also got bioschemas, which introduces types that are of interest to life sciences, such as taxons, proteins, genes, etc. And the Data Commons project provides a way of linking different types of public data sets, and it uses schema.org as a basis. So how do we actually use schema.org and these extensions? So we have a bit of a pathway towards generating APIs in various languages that I'll discuss. And I'll step through this process that involves these various technologies. So we start off with schema.org, and as I said, schema.org has numerous types that are of interest to us. One of them is the article type. And if you go to schema.org/article, you'll see the properties that are associated with an article, such as page start, page end. And what we're doing is converting those initially into a YAML file. So we're not taking all the properties of an article, we're only taking the ones that we currently have a use case for. So in this case, when we're converting from JATS, for example, we want to know the page start and page end of a article. And so we've encoded these properties from schema.org into this YAML file. The YAML, as you can see, has descriptions, but it also has some JSON schema attributes that I'll go into later on, which describe the expected types of, for instance, a page number. We expect it to be an integer or a string. So we do this with all the types that we want to use, and you'll also see the ID attribute here, which allows us to link back to schema.org. So having written a bunch of YAML files, if you look at the repo, you'll see a bunch of YAML files in there. We can then go on and convert to these other formats. I think that we've got a couple of principles before I go on to that I wanted to just highlight. We only implement the types if and when we have a use case. So we're not going to schema.org and saying we're going to implement all these types. We're only implementing the ones that we have a use case for right now. And we also are somewhat opinionated in our interpretation of schema.org. So we wanted to create something that was useful for developers who are working on executable documents. So we in some places make opinions or are opinionated about what the shape of a document should look like. So let's take the author property from a creative work, for example. In schema.org, everything is essentially described as a singular. So an creative work has an author property. What we do is say, well, we probably expect most papers to have several authors. And so instead of having an author property, we'll call it authors. We link through to the schema.author property, so we can retain that translation link, and we'll make it a type of array. Similarly, we also rename some of the properties. We try to avoid this if possible, but in some cases to avoid confusion, for instance, for citation here, we've renamed those to references just to fit in with existing usage in research. Another example is article or creative work has a headline property. Instead of calling it headline, we call it title. We have aliases encoded in this YAML so that we can, again, do that conversion through to the existing schema.org types. The other principle that's important is we reuse these existing schemas as much as possible. So we start off with the types and properties that are in schema.org, and we will use those where possible. If they're not available in schema.org, then we'll look to existing extensions such as code meta. We use the maintainer property from code meta. One of the ones we haven't implemented yet, but we're looking to do soon, is taxon from bioschemas. And then if there's no schema.org extensions that have the type we need, then we will then create new extensions. And here we're referring heavily to existing schemas that are not schema.org based. So an example here might be we've added the date accepted to an creative work, and that mirrors what's in JATS. We've had to implement a whole lot of types around the prose content of an article, and here there are a lot of existing schemas such as HTML, pandoc types, and others where we can draw on, so we don't need to heavily reinvent there. And then things like code chunks and code expressions that I'll show later on, we're making sure that when we implement them that we've got things that are compatible with existing formats like Jupyter Notebooks and R Markdown. So we've used those principles to write a bunch of YAML files, and we take those YAML files and then convert them into JSON schema. And why that's important is that it allows us to validate these documents. We're using a tool that's written in JavaScript called AJV, which allows us to, once we've done some conversion, ensure that that document that we've converted from a different format conforms to the schema that we've written. This JSON schema looks very similar to that YAML you'll see. We're just really using the YAML just because it's easier to write than writing JSON by hand. Once we've converted to JSON schema, we generate some JSON linked data, and this allows us to then connect our schema to other schemas. And so you can see this is the context that we generate from all the JSON schema files. It refers to schema.org and bioschemas, code meta, and so forth. And it tells us that when we talk about a brand, for instance, we're referring to the schema.org brand. But when we talk to a site, which is a citation in text, that this is the type that is defined in this schema. And then we're also generating from the JSON schema these bindings for different languages. So as part of the repo and part of the packages that we distribute in that schema, Stencila schema repo, bindings to Python, TypeScript, and R. And one of the neat things about this is that we then are able to reflect the types and the constraints that we've expressed in those YAML files initially into the different types and constructors, and you get all the advantages then of when you're developing, being able to get the type inference and tooltips that you see in tools like VS Code. We're doing that, as I said, for 3 languages at the moment. Here's an example for R where we don't have the same typing type annotations, but where we have error checking to make sure that when I set the authors, I'm not setting it to a paragraph and so forth. So this allows you within these languages to do things like generate semantically correct articles and potentially generate prose from your data within these languages. And as I said at the outset, the schema that we're showing today is sort of pervasive through all our tools, and we carry the semantics through. So that's why it's sort of important for us to get those right. We've been doing a lot of iteration between the schema project and encoder project, which is a converter that converts between a number of different languages. And you'll see that when we convert this code chunk, for example, to HTML, just as an example, we're carrying through the schema identifiers into the HTML. And we're even applying this in our theming library called Thema, which we're taking these semantic names around code chunks and headings and everything all the way through to our CSS selectors. So I'm going to pause there and open up for discussion.
I had a question.
Yeah, thanks.
So you said you're taking a sort of use case driven approach, like you're not adopting, like you're sort of focusing on the entities that you need and the types that you need. Could you say a little bit more about what types of users are driving those requirements? Like who your primary customers for the tool chain ultimately, and that I'd love to hear a bit more about that.
Yeah, so let me just take one example, which we've just recently completed with the executable research article project with eLife, where in that use case, we're looking to enrich, allow authors to enrich their existing published articles. So we're taking JATS and we needed a way to convert that JATS into our schema. So a lot of the things, as I was saying, like page start, page end, are driven by that use case where we're needing to encode everything that is in a JATS document back into our Markdown or Jupyter Notebooks, whichever format the author wants to use. The author is then enriching that, replacing figure nodes within that document with code chunks, and then we're converting that back to HTML to have that interactive article. So yeah, I think that's a use case that we've been working on more recently, and eventually we want to apply the same schema to the work that we're doing around spreadsheets and plugins to other platforms as well.
Right, so there's a question. Oh, I was going to say there's also a question from Alan Williams in the audience, but Vanessa, maybe first. I don't know.
Oh, I'll go quickly. So one thing I noticed about Stencila is that it has great transparency in the sense that you can go to the repository, you see all of the YAML files, you see how they're built, how they're tested. And this isn't necessarily true for all these kinds of communities. So my question is this something that you thought about beforehand to sort of foster a very welcoming community?
Yeah, I mean, that's been important from the outset, and so it's great to hear that you thought that. We've tried to make that effort, and I think a lot of people put that effort into creating welcoming environments. It doesn't necessarily mean that people are going to jump in and contribute. I think people need to have their own use case, and but we're starting to see people picking it up now. Yeah.
Definitions in various formats, RDF, Turtle, etc. And you are rewriting those?
Yes, yeah, largely. As I said,
so is that do you read the originals and then there is some definition as to how they are changed?
So that's mainly a manual process where we are, as I said, being somewhat opinionated about how we define things like an authors list, where we, instead of having just the property author, we will make that an array of authors, be that a string or a person node. Yeah, so we're not trying to be completely match the schema.org definitions.
Is there a reason for that?
We wanted to make something that was useful from the developer's perspective, in terms of when we, as I said, we're iterating with our conversion library encoder, and when we're doing that, we're just finding what works and what doesn't with alternative formats. So that was the main driver for having those deviations from schema.org. But as I said, having the JSON LD allows us to then translate back to schema.org and maintain that compatibility, so that in terms of the linking the vocabulary.
you've lost, as far as I understand it, you've already lost the mapping from schema.org to your derivations of it. Like, is there any file that says, you know, for author, then we are doing it as authors, so that it could be realized programmatically? So if you took something that was already annotated in schema.org, you would be able to get your version and vice versa.
Yeah. So the JSON LD file that we generate provides that mapping. So the JSON LD essentially provides that that crosswalk between the schema and the terms that we use in our schema and the ones that are in schema.org.
This is Thad. So I put something here in the chat there. Is the team aware that those particular you know, where we have singular properties, they are in fact can be used, and you know, they are typed arrays, so you're not limited in that regard. But was it just a preference, I guess, in the wording of the existing schema.org definitions and property names that you found more appealing, that you would reword that to pluralized form rather than the singular form that we have in schema.org?
Yeah, I think that captures it quite well. So it was really just a preference when we are developing or writing code. For instance, when we have an article, it's just makes more sense when you're writing code to have a property on an article that is a list of authors rather than an author.
Sure.
And so it's really was just representing that, trying to get some good developer experience around that.
Right. Okay. And then can you speak a little bit about?
Sorry, doesn't that mean that you're getting the developers to be used to something that isn't schema.org, but a strange mutation of it?
I think he's keeping the mapping, Alan. So the context is not lost. If you look at what they presented, those IDs, those identifiers are still there for the types. So that's applicable to JSON LD. So a JSON LD consumer, a program or human or whatever, would be able to make that inference through the mapping that they haven't applied. But I think what I'm concerned about, I guess, and maybe Alan is kind of hinting on or thinking about, is in the linked data world, you know, how much of this with Stencila is truly or really trying to embrace linked data, or maybe not quite as much just yet, right? Looking more focused at the, you know, at publishers and authors. And then this is kind of to Arfon's original question, is like, you know, what is the actual use cases there? What is the benefit? And it would be nice if you talked a little bit deeper about what is the intrinsic benefit for, you know, for those authors that you're really trying to expose. You know, is it actual true, quote unquote, linked data publishing, or not quite yet?
Yeah, so I think again, that summarizes it quite well. So we don't have, we're not quite there yet with linked data publishing, and we saw the advantage of using schema.org and JSON LD and that ability to do the crosswalks to different schemas as an advantage for that in the future. Right now, we really just said we need a data model that allows us to convert between these different formats, and which allows us to extend it to introduce things like code chunks and code expressions, can we do that in a way that will enable that linked data research in the future?
Right. And so for now, the primary focus, it sounds like, is on the validity side and the type inference and being able to make those checks, right?
Yeah.
In a programmatic way. But the hope is that beyond that, true linked data publishing could maybe be a happenstance with that.
Yeah, I think we are quite close to having that already, in that we're able to produce, like for instance, an R Markdown document. From the R Markdown document, create semantic HTML, which is annotated with schema.org properties and types. And so we automatically have an HTML document that's highly discoverable.
Oh, I see. Okay. Is that part of the encoder?
Yeah, yeah.
The output? I see. Okay.
So I'll maybe just get into showing you some of that right now. Yeah.
Yeah, I was going to quickly say, I think a really good example also beyond like traditional publishing is for schema.org's dataset, which is by far my favorite entity. And that basically powers into Google dataset search. And that was a huge thing because it meant that researchers at so many different institutions started adding that metadata to their pages, and all of a sudden you have this dataset search. So that sort of basic thing, it's just an example of how that can really empower people to like find what they're looking for, which is like a huge problem, and it definitely shouldn't be. And also, why I didn't see dataset in Stencila. Is it just not added yet because it hasn't been kind of pointed out, or?
Yeah, we just haven't had the use case for it right now.
Okay, let's add it. I'll make a use case.
I think that sort of like builds on the discussion a little bit about linked data, but I wasn't sure if in Stencila you had any aspirations or intentions of taking advantage of any of the transformation algorithms that are available via JSON-LD. So I don't know, example frames or anything like that. If that was anything that you guys were considering, you know, working more with. Like,
so
take full advantage of the format.
We are using some of that in Encoder, which is our conversion library, to transform, for instance, from things like existing APIs like ORCID IDs and so forth. So we are using some of that already, but we haven't done a deep dive into it.
Okay.
I'll keep on going and we can pick up some of the questions later on. And I think as I keep on going, you'll see some of the use cases and answer some of the questions that just came up. So as I mentioned, we're going to go into the types that we've got for metadata and prose. We already have a lot of metadata related types available in schema.org. And so we didn't have to do much extension here. Schema.org obviously has a lot of these types, such as person, monetary, grants, so forth. One of the key types that I will point out is the creative work, which has many properties for us that are of relevance for representing articles, research articles. Where schema.org doesn't have existing types, many existing types anyway, there are a few around things like web pages, but that is around the prose or the content, the body of an article. And so we've created some extensions here that broadly fall into two groups around inline content and block content. And as I mentioned before, we also didn't need to do much invention here because we could draw on existing schemas such as JATS, Markdown, open document formats, pandoc types, for instance, which already have schemas that are quite well defined for these types. You'll see that there's a range of things that we needed to encode to capture things that are in articles such as subscripts, superscripts, and each of these are represented as an entity within the document tree. I might just jump in here with, and I'll talk about this conversion that I was mentioning before, but then I might just get Paul to talk about how they're using some of this in their work with preprints. This is an example of how we do some of our conversion. So we have an R Markdown document here, which includes a citation to bibliographic item number 3. It's got a link to a figure, and it's got an inline code expression. Our conversion software will take that and convert it to the JSON schema that we've defined. You'll see that it looks like JSON LD. We are not using the at type, we're just using the type. And then we have these properties such as title, content, and the code expression, for example, which is the extension that we've added, which uses property names that already exist in schema.org, such as programming language. And then we have the text of that code expression. When we convert that to HTML, as I was mentioning before, we carry across all the types and the semantics. So the article gets encoded as a HTML element article, but we annotate it with the item type schema.org article. And as Thad pointed out before, because we have the JSON LD, the context, we're able to translate all our types back into schema.org types, or our extensions where they're not in schema.org. So these are annotated all the way through with paragraphs and so forth, and code expressions. This does a couple of things. One, it allows these documents to be highly discoverable. So if you put this through Google's structured data testing tool, you'll see that it's able to see all the people that are named in this as authors in this article. But it also, we use it elsewhere when we're actually doing styling of these documents, and I'll show that later on. I might just get Paul just to discuss some of the work they've been doing around preprints with us.
Yeah, sure. So at eLife, our goal has always been to be open and allow people to consume our data. Our first iteration was that we built some software to power the eLife journal, so elifesciences.org, and that software is still there. Behind the scenes is an API, but when you're a publisher and you work in publishing, you tend to see everything as a publisher. So we created a JSON version of JATS XML, just because as software developers, it was easy to work with the JSON versus the XML. And it wasn't widely adopted. It was particularly esoteric to eLife, who were trying to push some boundaries in publishing, so included perhaps more data than a lot of people. So that ended up being a bit of a barrier for adoption of our software. So that was sort of two or 3 years ago. And then we looked at making our software more broadly applicable to other publishers so they could reuse it as well. So that's when we started looking at things like schema.org, but actually sort of started to look at more extensible ways of passing XML around. And again, I think we're still looking at that as from a publisher's point of view. So then when we came to start working on our preprint and review platform, that, you know, we've been working with Stencila on the executable research article project as well. And we thought, well, let's just give it a go. Let's just see what is available there, because we know there's barriers to entry because people have got to learn our specific API and our specific way of doing things. And also everybody has a slightly different way of encoding their articles around preprints and in publishing and things. So we wanted to have something that was a little more core, if you like, or that you could translate into. So that's why schema.org made a lot of sense to us. And the extensions that have been added through Stencila meant that we think, I just checked, we've got a list of 7 things that we added. And because this ethos of see what's in there and only add something if there's a real use case for it, we've been able to drive that a little further forward. So it's interesting you mentioned data set, because that's something that we're looking at in the future to adding. We want to promote open science practices, and that's a great thing to. It's one thing getting people to open their data. The next thing, to making it easily available and well described and things like that is another section. So we've been using the encoder tool to take a JATS XML file convert it into JSON LD, and then we're simply just storing that in a local data store to our application, and then serving that out through a hypermedia API that that has 2 or 3 use cases. The first one is just to present the article as a web page, so we can have a full HTML version of a preprint, which we're working with content on bioRxiv, and we've been looking at their text data mining strategies, and they're exposing a lot of the XML that they're transforming their PDFs into, but we're also working on tools where we can take PDFs and turn them into XML in JATs. And as we're looking at all these different ways to get data in, we're finding that having a central way to transform data like schema.org and like having a JSON LD is really aiding that sort of ecosystem to grow around this central place. And right now, most preprints are just PDFs, and then you'll get some XML files, some Excel files to go with it with the data. And we want to try and push that a little further forward. So it's in the early days for what we've been doing, but what we've found is that our team had sort of thought it might take them 4 or 5 weeks to be able to do the document conversion side of the project, but by using the work from Stencila, it's really shortcutted that for us quite a bit. So we've been able to start thinking slightly further forward on how we're going to expand the schema. So and that means that there's other 2 parts of the use case for our API. The first is just taking parts of an article that we want to display alongside reviews, so that we can start putting reviews and preprints together. And we're taking a real user-centric approach to the way we're building our platform, so that we can respond to what real scientists actually want to read. And what we found out, it's not just putting every single possible bit of data on one massive page. So picking out the bits that you need at the right time is very important. So that's sort of the main use case for this. But also exposing that API, and hopefully if this platform takes off, having the ability to expose any preprint in a standard format using well-known structured data like schema.org means that hopefully we can help text data mining projects, projects that are aggregating data from on early release science to really accelerate what they're doing. And that's all part of our mission at eLife.
Thanks, Paul. I'm just conscious of the time, so I'll keep going and we'll stop for discussion after this next section. That was a brief overview of the metadata and the types that we've added for dealing with prose within articles, and Paul's just described how they're using that for preprints and helping out with the conversion. We've also got types that we've added around data, and we haven't spent a lot of time on this. It's been less of a focus recently. So in answer to Vanessa's earlier question, we do have things around data and data tables in particular, where we're trying to represent columnar data. There's also here existing work there's been a lot of work done on this around web CSV and so forth. But we've put together some existing types that we're using, and we've really just in a proof of concept stage with this, where we're looking at, can we, for instance, convert a spreadsheet? So here we've got an Excel spreadsheet that conversion software is converting through to a data table, and a data table is a type that we've added, which is very similar to the frictionless data, tabular data column, tabular data package specification, where we're expressing this spreadsheet, which only has data in it as JSON with the data, 2 data columns, A and B, with a sheet. The major thing that we've been focusing is really around the code and extensions there. We, as I said earlier on, have been referring back to, importantly, Jupyter notebooks, which already have a schema defined for code chunks and as well as for Markdown, and making sure that we've got some compatibility there. As I mentioned before, we carry through the semantics throughout the different formats that we're converting to. So here you can see a code chunk that in this case uses R as a programming language and has some code in it. When we're converting that to HTML using encoder, we carry through those semantics and we're actually encoding it as a web component that goes into the web pages. When you see the HTML document, as I showed you before, we annotate all the items, the elements in the HTML documents that get published with item types. And in this case, you can see the code expressions have come through into from the markdown through into the HTML. When a user actually executes one of these documents and presses the little play button here, what's happening is that that code expression is actually getting re-encoded as JSON and getting sent to the R session, and it's calculating the output, which in this case is 1.43, stamping the time that it took to execute that bit of code and returning the result. And the main reason I wanted to show you this was, again, just to show you how pervasive the schema is in our platform. We're actually here sending these nodes, document nodes, as JSON, just as we saw them originally converted from R Markdown across the wire, across the WebSocket to the R and back again. And here's another example of using a code expression. Here we have an Excel spreadsheet, which this time has an equation in one of the cells, and encoder conversion software recognizes the fact that this spreadsheet has some calculations in it, and then actually creates a table node. And this table node has data, but then one of the cells is a code expression. So let's open it up there for more general discussion, and I'll try and catch up on some of the questions that were in the document.
I have an easy question. Are there design templates? So you can imagine that you'd want to render that particular notebook or whatever you want to call it that you showed me with different, styles. So is there a plan, or do there already exist different design templates just basically for those HTML elements so you can customize the style?
Yeah, so we have a package, a repo called Thema, which is the theming library. And what we do there is to implement using CSS different themes. The rationale being, let's generate one set of HTML that is heavily marked up as, but semantically marked up, as I showed you before. And then we use CSS and JavaScript to then theme that in alternative ways. And we've been really happy with the results of that. We're able to quite easily theme a document for different journals without writing a whole lot of code.
Awesome, thank you.
I'm just reading through here some of the questions. Yeah, do we plan to incorporate some use of rich types in frictionless data tables schema? I'm not sure about rich types. I haven't looked at those. As I said, we have got a converter from frictionless data table, frictionless data packages, and we've been exploring that, but I'm not familiar with the rich types yet.
Yeah, so that was my question. So you can, in that link, you'll see the example. So they support, the RDF type. So like, schema.org/country is the example.
Right.
So you can expose the RDF class.
Yeah.
So something to look into, I guess.
Yeah.
I did hear mention that you had looked at the CSV on the web, so that's good to hear. So this might be another way to, depending on what level you want to, or how rich your semantic typing you want to do within the data tables themselves. But this might be a way to do that.
Yeah, thanks, that's useful.
Sure. And my other question was right before that was about the either RDF or JSON LD. I guess it seems like what you're publishing currently from those contexts. You know, I tried to browse it, but it looks like it's, I guess it's only HTML with microdata embedded. There's not a way to get the JSON or RDF output.
Yeah, from a published document, we're just annotating the HTML.
Okay.
Yeah. So we decided we avoided like putting the JSON LD. We could put the whole document as JSON LD into the header,
right?
But we avoided duplicating that.
Okay. Okay, that's fine.
But thanks. Yeah, with the converter software, you can export it. You could take, for instance, a Jupyter Notebook and export it as JSON LD or JSON. So. Yeah,
I really would like to see, you know, JSON LD. I think, I think most people would. So yeah, if you could have plans for that in the future, that'd be great.
Okay. Thanks for all the suggestions here. Let me see what other questions. There was mention of Open Refine. How do you deal with user input control? So we haven't, I think, just to answer that question, we haven't done a lot of work with user input control at this stage. We are really focused on that conversion. So for instance, if someone's using Markdown as their preferred format to author one of these articles, they're obviously writing Markdown. We don't have a user interface that presents forms for adding this metadata, for example. We would like to add that in the future, but at the moment, it's up to the authors to use the format that one of the formats we support. Well, I was going to try and answer some of these questions in the Google Doc, but I still we're up for the hour. So unless anyone wants to ask a particular question, I might just wrap it up now.
I want to ask one more question for everyone in the chat. So let's say that I am sort of someone interested in this effort. How do you want people to sort of contribute? How do you want people to help?
Thanks very much. That's a great question. So yeah, if people can just look at the repo, for instance, the schema.org, the Stencila schema repo, and just browse it and try and understand if you think there's things missing with documentation, create an issue, even better, create a PR to add some of the documentation and clarifications there. Using some of our tools that use the Stencila schema, such as Encoder and the Stencila Hub, which makes it a whole lot easier, will help us just iron out a lot of the bug fixes and the holes that we have in that schema. Great. Well, thanks very much all for attending the call. Thanks very much in particular to our panelists for taking time out of the day to come along. And yeah, hope you can join us for some of our other webinars that we'll be having coming up.
Looking forward to the invites.
Thanks, everyone. Bye.
Thank you. Bye.